Good morning, good afternoon, good evening, or whatever time it is. I hope that you're having a good time. I'm Andrew Komazinski at Hokkaido University of Education in Asahikawa, and this is the fifth in a series of videos about critical thinking. This is the fourth one that students will be required to do as homework. And today we are going to start looking at deductive arguments, or in Japanese, enekiteki ronsho. So the first thing we want to do is to look at some vocabulary terms and do a little bit of review. So let's go ahead and get started. So there are several words that will be important for what we're talking about here. Some will have a normal meaning, and some will have meanings that are a little bit different than the normal meaning. So let's just go ahead. So contradiction. Contradiction is when two things are not able to be true at the same time, that they're the opposite things that are true at the same time. Excluded. Excluded is when something is not a part of something. Fukumete nai. Disjunction and disjunctive simply mean or. Conjunction. This is also a large word with a small meaning. For our purposes, you can think of conjunction as simply meaning and. A hypothetical is a sentence that begins if. So this is a hypothetical. Syllogism is an old word for an argument. In fact, it's a word that Aristotle came up with. And the basic concept is an argument with three terms. So the word probable. The word probable means most likely, or that something is likely. 確率が高い or 確率がある. Other words that are very important for what we're going to talk about have special meanings. These meanings are not the usual meanings of words. One is the meaning of the word deductive. So I've given you the Japanese for it, enekiteki. Please think of it with just that meaning. So another meaning of deductive or deduction is to subtract, but we are not using it with that meaning. Another pair of concepts are the words strong and weak, which we will look at more later on. But what I want you to understand now is when talking about deductive arguments, we don't call them strong or weak. And we'll see why today. Instead, we like to call them valid and invalid. Now, if you look this up in your dictionary, what you may get is that this is a word that also means strong, and the invalid would mean something like not strong. Instead, I want you to think of these words as having the meaning dato. Now, you may not know this meaning. So that's one of the main things we'll be looking at in this class, is how to understand an argument in this way. So sound has a special meaning. Here sound is an adjective. And the special meaning is a valid argument where all of the premises are true. So I will repeat that definition when we get to the important part where we're talking about that. Inductive. So inductive is, in this case, also a type of argument. And that's what we'll look at in the second half of this course. Now, you also need to remember what a statement is. Something that can be true or false. Now, another word that will have a special meaning in arguments is the word dilemma. So the regular meaning of dilemma is that you have a choice. But in arguments, this refers to a particular structure which we'll look at later today. So let's review the previous lectures that we've gone through so far. We've mostly looked at general rules. And the general rules that we've been focusing on are: first, find the premises and the conclusion. Second, use a natural argument order. So either do premise, premise, conclusion, like this, or do conclusion, premise, premise, like that. The other thing that we've talked about is what it would mean for an argument to be good or bad. And the basic idea is that good means to convince, means it is able to tell us something using, hopefully, logic. Now, I summarized some of them under the heading be clear. So being clear has three parts to it. One is to be concrete. So make your point in ways where you're making your point. Don't elide what you're saying. Don't say it in a very indirect way. Be, in Japanese, gutaiteki when you make your argument. The second one is to be concise. Now, concise is a big word, but concise means to use as few words as you need to say what you need to say. So, the point of being concise is not to talk too much. Be consistent. So when you're making an argument, try to use the same words to make the same point. Don't change the words to talk about the same thing. Finally, we want to build on argumentation, not emotional or loaded language. So when we pick words for our arguments, we want to pick words that have very neutral and very normal meanings. I want to remind you again of a very important concept. I've already mentioned it once today, but I want to mention it again. A statement is a claim that can be either true or false. And that means that statements are usually, but not always, declarative sentences. So you've seen this slide before. So here's an example. The sky is blue. This is a declarative statement. Alright? How are you? This is not a statement. Because I don't know what it means to say this is true or to say this is false. Again, same thing with an exclamation. I don't know what it would mean to call it true or false. Now I'd like to begin the material for this week. So I want to talk to you about the value of deductive arguments. So there's a way to argue that guarantees a true conclusion if the premises are true. This is called a deductive argument. Moreover, we can see whether an argument is deductive without knowing anything about the truth of its premises. So I want to point something out here. And what I want to point out is that there's this important word, if. So we'll talk more about that later. But what I am not saying is that if an argument has deductive form, that the argument's conclusion is true. Let me repeat that. I am not saying if the argument has deductive form, then the argument's conclusion is true. What I am saying is that if the argument has deductive form and its premises are true, then its conclusion is true. So, if we have false premises or other form, it doesn't matter whether we have either deductive form or true. If we have true premises and deductive form, this guarantees, this will guarantee us a true conclusion. If we have false premises and deductive form, I don't know if the conclusion is true. If we have false premises and some other form, I have no idea if the conclusion is true. If we have true premises and some other form, we have no guarantee of a true conclusion. So this is important. I will explain this a couple of other times later in the class, but I just want to put this out there. So again, a deductive argument which has both deductive form and true premises will guarantee a true conclusion. So there's something else that we need to talk about in order to understand deductive arguments. And to do that, we need to look at an idea from Aristotle. Now, Aristotle is probably the most important philosopher in history. Second only to Plato in terms of how famous he is, but perhaps more important because Aristotle helps to build a system. So, Aristotle has 3 laws that he thinks are true in logic. The first law is the law of identity. Now, the law of identity says this: A is the same as itself. So we can symbolize this as A equals A. So what does that mean? It means that whenever we use the same term, we're pointing to the same thing, and that thing stays the same. Let me give you some examples. So, a dog is a dog. That follows the law of identity. Dr. K is Dr. K. That follows the law of identity. A sunny day is a sunny day. That follows the law of identity. These things break the law of identity. To say that a dog is a cat. To say that Crayon-chan is Ampaman. This breaks the law of identity. They're 2 different characters. They're 2 different people. So obviously there could be some harder cases. So is Batman Bruce Wayne? These things are complex. But the basic rule is that whatever is on the left is the same as what's on the right. So the benefit of the law of identity is that it makes our arguments easier to follow and avoids tricky situations. Now, the law of identity is too obvious. When you hear this law, you think, why do we need this law? Now, it relates back to our idea that when we make arguments, we need to be clear. And in this way, it relates to consistency. Now, the challenge is language does not always work this way. Sometimes the same word will have different meanings. So, let's go on to the next law. The next law is the law of non-contradiction. A and not A cannot both be true when A has the same meaning in both cases. So, that gives us this simple way to write the law. Not A and not A. What we are saying is we cannot at the same time say one thing is true and the same thing is false. So let me give you some examples. You cannot be both a man and not a man at the same time. You cannot be both passing and failing this class at the same time. These are examples of following the law of non-contradiction. Examples of breaking the law of non-contradiction. Fido is a dog and not a dog. Crayon Shinchan is Ampaman and is not Ampaman. These break it because we are saying something both is and is not the same thing. Is and is not the same thing. So that's impossible. Okay, what does this law do for us? The law of non-contradiction is a bedrock of logical thinking. It relates to our idea of being reasonable. It makes it so we can work towards a single conclusion. The benefit is that this excludes some complex puzzles. It makes it so we don't have to deal with things that are seemingly both true and false. The challenge is that sometimes it feels like we are cheating because it helps to make things so much easier. While we might think all of these rules are painfully obvious, they are important for us because they help us to understand the rules that we'll use for deductive arguments. Finally, the law of the excluded middle. Of A and not A, only one can be true when A has the same meaning. So we can write this as A or not A. So this is a very valuable argumentative technique. So let me give you some examples. Fido is a dog or is not a dog. It is raining, So in this case, I only write one claim. But it is raining excludes that it is not raining. So again, this law is called the law of the excluded middle, which is to say that we make a choice and it is either true or it is false. We can't be in the middle. So an example of breaking this law, the sentence, they may have scored a goal. So we need to know, did they score a goal or did they not score a goal? And it's not clear. Crayon Shinchan is maybe anpaman. So this again is an example of breaking this law because it's somewhere in the middle. This is probably the hardest of the laws to understand. So I'm going to start with some easy cases. Things that we just wouldn't say because they break the law of the excluded middle. The computer is half on. We either turn a computer on or we turn a computer off. I don't really know what it means for a computer to be half on. The dog is half alive. Now, either the dog is alive or it is not alive. It is half night now. It's either day or night. I don't know what half night means. Now, there's harder cases. So we have things like he's half asleep. But even when we say the sentence he's half asleep, either he is asleep or he is not asleep. The window is half open. So you can open a window part of the way. This sort of sentence will not work in deductive arguments, because deductive arguments need every sentence to be true or false. I kind of like Katoya's ramen. Again, this can be true about me, but it won't work in deductive arguments. So the benefit is that everything has to be either true or false in a deductive argument. The challenge is that not everything in life splits so easily. So some things in life are more complicated. Alright, so let's look at a few special words in deductive arguments. First special word in deductive arguments is the word not. Now, the word not means that something is true when its opposite is false. Snow is not warm. The word and means that something is true when both parts are true. Hokkaido is cold in winter and snow is not warm. The word or is true when either part is true. So either we are in Asahikawa or we are not. If then. In an if-then sentence, it's true if one thing implies another. So if one object strikes another, the second will move in relation to their masses. So, I want to talk a little bit more about conditionals, and then hopefully we will understand these by practicing them and through some examples. We'll also work on that in the next flip. So, if America wins against Germany, then they will enter the tournament stage of the World Cup. There's two important English words that I will use in this class. One is the word antecedent. The other is the word consequent. The antecedent is the top part of this. The consequent is the bottom part of this. So the antecedent is the condition that has to happen for the consequent to happen. So these are two parts of the words we use to talk about conditionals. So in the remainder of this class, I want to show you 5 standard argument patterns for making deductive arguments. Alright, let's get going. Standard argument patterns. The first pattern I want to talk to you about is modus ponens. So this is maybe the easiest pattern that there is. So if people are thirsty, then people should drink water. People are thirsty. Therefore, people should drink water. If you want to stay in Japan, then you should learn Japanese. You want to stay in Japan, therefore you should learn Japanese. So the pattern is extremely easy. The pattern is if P, then Q, P, therefore Q. So if you look, here is your if P, then Q. Here is your P. And then here is your Q. So this is P. This is Q. this is P again. And from that we can say Q. So you can also write this using some symbols. So if you're a math major, or if for some reason you've had this before, you might recognize these symbols. So if P then Q, P therefore Q. Modus tollens. If I'm using an umbrella, then it is raining. It is not raining, therefore I'm not using an umbrella. If you are learning French, you are taking a French class or reading a French book. You are not taking a French class or reading a French book, therefore you are not learning French. Alright, so let's just think in pieces. So again, we have P, then Q. But now we have not Q. And then finally we have not P. And this is our pattern. So if P then Q, not Q, therefore not P. This is modus ponens. So again, the main difference here is that now our second statement is not Q. In modus ponens, our second statement is P. They have the same first statement, different second statement. Alright, and again we can symbolize this, and if we do that, we're going to get P implies Q, not Q, therefore not P. Third standard deductive pattern. This is the hypothetical syllogism. If I'm using an umbrella, then it is raining. If it is raining, then flights are delayed. Therefore, if I'm using an umbrella, flights are delayed. If you eat tuna, you are part of overfishing. If you're part of overfishing, you should feel guilt. If you eat tuna, you should feel guilt. So I believe this is not actually true, but I'm not sure. Here's the pattern. So, P then Q, Q then R, P then R. So sometimes this will also be called the chain rule, because we are chaining together two different hypothetical statements. So again, P then Q, Q then R, P then R. One hint that will help you find this sort of argument is if the conclusion has an if-then pattern, this is the most likely candidate. So, here's the pattern. If P then Q, if Q then R, therefore if P then R. P implies Q, Q implies R, therefore P implies R. Okay, another pattern. This is a disjunctive syllogism. So one of the hints that we have is the word disjunction, which we have here, is a word that means or. So this is the first pattern we've looked at that has an or in the pattern. So either I am married or single. I am not single, therefore I am married. So we could write this as M or S. Not S, therefore M. You can get to Honshu by train or by airplane. You did not go by airplane, therefore you went by train. So, pattern, P or Q, not P, therefore Q. Symbolization, P or Q, not P, therefore Q. Finally, I want to talk about the fifth pattern. This is the most complicated one, and I'm going to give you two different versions of it. So Dr. K either made the flight or he did not. If he made the flight, he will eat steak on the plane. If he missed the flight, he will eat at hamazushi. Therefore, Dr. K will either eat steak or hamazushi. So, what's the pattern? So let's begin just by picking some names for things. So let's call made the flight F. It's called not making the flight Q. So then we have F implies, say, steak. We have Q implies H. So our first one is F or Q. F implies S, Q implies H. Therefore, S or H. Now, how did we get that conclusion? The answer is that this is like mixing a hypothetical syllogism and a disjunctive syllogism together. So we can look at both sides of it. So let's just look at the symbolization. So it's P or Q, if P then R, if Q then S, therefore R or S. So again, symbolize it in this way, P or Q, P implies R, Q implies S, therefore R or S. Second version. So Stephanie is either in Sapporo or Asahikawa. If Stephanie is in Sapporo, she wants to eat udon. If she is in Asahikawa, she wants to eat udon. Therefore, Stephanie wants to eat udon. So let's do the same thing. So let's say that this is S, this is A. Let's say wants to eat udon is U. So then if we do that, we have the following pattern. S or A. S implies U, A implies U. And we are going to conclude with U. So, here we go. S or A, if S then U, if A then U, therefore U. Symbolized over there. So today, what we've done is we've looked at 5 patterns for deductive arguments. We've looked at modus ponens. We have looked at modus tollens. We have looked at hypothetical syllogism. We have looked at disjunctive syllogism. And we have looked at dilemma. So I just wanted to give you a hint so you can know which is which. So here's the hint. The only patterns that have not are modus tollens and disjunctive syllogism. The only patterns that have or are disjunctive syllogism and dilemma. And 4 of the patterns have if, modus ponens, modus tollens, hypothetical syllogism, and dilemma. So, if you look for these features, you can know which ones it is or is not. So, there is no not in modus ponens, there is no not in hypothetical syllogism, there is no not in a dilemma. There is no if in the disjunctive syllogism. There is no or in the hypothetical syllogism, the modus tollens, or the modus ponens. So, in future weeks, I'm going to talk to you more about what makes these arguments deductive patterns. For right now, though, I want you just to learn them as deductive patterns. So I hope that you enjoyed watching this. If you have any questions, please feel free to ask me during class. I will be making sure you watch these videos because I will be quizzing you on the content of the videos. So I hope that you had a pleasant day, and I look forward to seeing you.